All right, so hey guys, this is Ignited Minds Lesson 2, and today we're going over key concepts in data science. So basically, what we are going over today is working with data. And before you pursue your data science projects, obviously the first thing you need is data. Data science runs on data. And so without good data and without working with data well, your data science project is doomed from the start. So let's see how you can effectively do that. As a brief recap, last time we studied an introduction to data science, and we studied two parts about it. Number one, we studied the many aspects to data science. In data science, you have mathematics, computer science, and domain expertise. And domain expertise, if you guys don't remember, is basically your knowledge in a certain field that you want to apply data science to. And all of these aspects combine together to form many more aspects of data science that ultimately allow you to use data science to make change, real world change, and have big impacts on society. And as you can see, there's many domains to which you can apply this in society, such as business, government, or healthcare. So when we look at working with data, we're looking at the first half of the data science workflow. So we don't look at model building and putting out models, but we look at collection, cleaning, and exploratory data analysis. Now, I covered the data science workflow in the last lesson very briefly. And what it is it's the set of steps that you must follow when doing a data science project. And we won't cover the whole data science workflow this time. That'll be next time. But today we're only covering the first half, which is working with data. So we have three steps. The first is data collection. The first is data cleaning or data pre-processing. And the second is data analysis. So let's look into these three steps. The first step we have is data collection. In data collection, we have to take raw data. And to take raw data, there are generally two ways you would do this: surveys and experiments. In surveys and experiments, you want to do these in a good way. You want to collect the data well so that the data can accurately represent the population that you want to study. If you don't collect the data well, your data science project won't be representative of the actual population as a whole, and it won't be accurate from the start, no matter how good your model is or how good your data analysis is when the data itself is wrong. So these three different parts of working with data obviously are usually handled by various different teams and are usually very extensive processes in and of themselves. But for the sake of today, let's assume that you will be doing all three. So in a survey, let's go over the effective ways to pursue surveys and experiments. In a survey, you usually want to take a random sample of the population. So obviously, you cannot ask everybody in the whole wide world or the whole population the question you want to ask. For example, maybe you want to study how many people like milk, and you want to study the population of all of Asia. But you don't want to ask all the billion people in Asia if they like milk or not. That'd just be ineffective. So you have to take a random sample of that population so that you can survey much less people, yet get similar results. But in order to take a random sample, you need to actually make it random, and you need to make it so that they're spread across the entire population. And there are many methods to do this, such as stratified random sampling, cluster sampling, but I will not go over those as those may take a little too long for this lesson. But for an experiment, you usually can make your own data. And what you can do with an experiment is you can take a bunch of subjects which can be objects or people, and you can assign them to different treatments. And treatments could be like, hey, let's say we have the same question of people drinking milk. So you can assign people the treatment of milk and no milk, and then say, hey, which one do you like better? And in experiments, you also need to randomly assign treatments. So what these surveys and experiments rely on a lot of the time is randomness. If it's not random, this could lead to some bias in the survey and experiment. And since they're not asking everyone in the population, then, there's obviously lots of room for error. And you must make a experiment and survey as accurate as possible but as easy as possible to do as well, as you're not surveying the whole population. And then once you have all this raw data, you should transfer them or transform them into usable formats. And these are usually spreadsheets, like Google Sheets, Excel, or CSV files. But CSV files are usually the most popular in data science as it's highly compatible with many languages, meaning many languages would have lots of functions that go with using CSV files. Let's take R, for example. So here I have an example of a CSV file on Kaggle in the right box, and it's called alzheimerdata.csv. It's basically a data set about patients with Alzheimer's. And as you can see, each column on the left is a unique patient with a unique patient ID. For example, S060833. And then each respective column after is a trait about them or a variable. For example, diagnosis, age, education, whether they're female or not, and their height. And as you can see, the raw data that they took about each and every patient is now put into a format that's usable online. This spreadsheet right here. And spreadsheets are usually organized into rows and columns like this. Now, the second step in working with data is data pre-processing. It's basically fixing the flaws in the data, making the data accurate. So if we go back, we can see that we made the data usable, but that doesn't necessarily mean the data is good. And to make our data good, there are many ways to do this, depending on what flaws the code may have. So depending on what flaws the spreadsheet may have, there's many ways to do this. For example, removing duplicates or a bunch of other stuff, but there would be too many to go over, as for every single one of your data science projects, you may need to meet a different requirement. For example, sometimes there are errors in my data analysis when some of my values have NA values, meaning they couldn't get a value for that specific variable. So I would have to do something called omitting the NAs, which is making all the NAs from the data set go away. But as an example, I will provide an imbalanced data set, which is a very common problem. This image below is an example of a table in the R programming language, and it's about a spreadsheet of data science jobs. So at first, I made a table of the data, the job titles in the data, meaning the different types of jobs in the data, and each is a variable. And it basically shows each variable with the amount of people who were in that variable. So we had applied scientists, BI data analysis, BI developers with 30, 15, and 11 people. But then when you went to other variables, you had data engineers with 529 and data scientists with 492. Now, since this data set is so imbalanced, when you have projects trying to use this data set, it will lead to much more bias in the data scientists and the data engineers, as it's trained on the data that we give it. And so if we give it much more data for one type of variable and you try to predict a type of variable based on certain qualities, it will want to predict the variable with much more people a lot more. And so what you can do is use upscaling or downscaling as you can see, this line of code right here in data equals smote. You don't need to worry about that, but what it does is it can upscale your code to kind of multiply the amount of people in certain areas and downscale the amount of people in other areas to make it more even. So as you can see in the new job title data, the amount of people are much more even and much more balanced. And so it would make the code and the models about it a lot more accurate, and you can analyze the data correctly. And even though the people are multiplied, it does not lose much accuracy because they're multiplied based on the existing variables around it already. So yeah, just whenever you have a data science project and you want to before diving in and before immediately analyzing your data and making your model, always make sure your data is pre-processed and think about any flaws that it might have. And sometimes the flaws just appear and become obvious to you. And then you can just fix it on the go. But usually it's better to just fix it at first. And the final step in working with data is data analysis. Now, this is usually done with data visualization, as this can present your data in your data set and what you have in a way that makes it easy to analyze. And this is usually done with packages in programming and data science. And so, for example, ggplot2 is a package in R. And what that does is, as you see the two images right here, the first one is a box plot and the second is a bar graph. And these are based on the Alzheimer's data I showed you in step 1 right here. The first is a box plot comparing diagnosis to a variable called NAC-ICD, which is the intracranial volume or the volume in the brain. And it shows you how for each diagnosis, for the diagnosis 0, which means no Alzheimer's, 1 mild Alzheimer's, and 2 severe Alzheimer's, there actually wasn't much of a change in brain volume. Now, I won't dive into the big details of that, but what you just need to know is in visualizing your data and data analysis, it makes it much easier for you to see trends in a format like this rather than in a format like this with Alzheimer's data CSV. You can see the trends much more easily, and it makes analyzing the data much more easy. But you must do this for every variable that you want to look at. For example, let's say a research question was, how does brain volume affect Alzheimer's? And this graph would help you do that a lot. You don't want to focus on variables that don't relate to your question. For example, like, if what the patient liked or how old the patient was, because that doesn't relate to our research question, but this graph would. And basically, data visualization allows you to do 3 things: visualizing trends, gauging the importance of variables, and narrowing down the focus for models. So the point of data analysis and working with data is ultimately to use that data set for models that can kind of predict the future in data science. And when you visualize trends, you can gauge the importance of variables or see, hey, this variable is more important than that variable in predicting this. And so you want to focus on those variables in the models to ultimately see how big of an impact they play in your data science project. So let's go back to that Alzheimer's example of the research question. If you wanted to look at how the different parts of the brain affected your Alzheimer's diagnosis, you would look at each part of the brain and compare it to your Alzheimer's diagnosis in multiple graphs. And when you see a trend, like right here in this bar graph, whoops, when one bar is much higher than the other, it can show you that there must be something significant about that variable. And in the model, for visualization is just to see trends. So if you just see a trend, make note of it at first. And when you eventually, when you make your model, you can see if that trend is actually significant or just based on luck or random chance. But yeah, ultimately, data visualization and data analysis, you look for a correlation, but then with the models, you can ultimately see if there is causation. So yeah, those are the 3 steps of working with data. And next time, I'm going to focus on the whole data science workflow with building the models at the end. This is a link to my Alzheimer's project that I have online, if you guys want to use that for reference.
Can you take a photo?
And yeah, thank you guys for listening. Do you guys have any questions?
Maybe, hello, can you hear me?
Yes.
Maybe please bring back the link so that we can capture it.
Yes. I will put that in
Maybe
the
you
chat.
can post it on the group.
So basically, it uses the Kaggle online data science community, and it can allow you to make data science projects on your own. So across the world, you could show various people different data science projects. I can also post that link in the WhatsApp group chat. But yeah, let me just stop the recording real quick.